these three graphs. So graph 1, graph 2, graph 3. On graph 1, we're going to try to find the x-intercepts. So x-intercepts means where a graph, like this one right here, crosses the x-axis. And the x-axis is the one that goes horizontal. So you're trying to figure out where this red line crosses the x-axis. I just highlighted it to make it a little more clear what I'm talking about. It crosses it at that point right there. That point is at -1, -2, -3, comma 0. It didn't go up or down. That's called an x-intercept. X-intercepts, there could be many of them. There could be like 1,000 of them in one graph. This one only had one. If you look at graph 2, you'll notice there's actually 2 x-intercepts. You have an x-intercept here, and an x-intercept here. The first one was at -1, -2, comma 0. And the third one is at 1, 2, 3. On graph 3, there's also 2 x-intercepts. I want you to draw the dot on them on your own sheet, and then fill in where their actual ordered pair locations are. Right, so find those dots on graph 3, a circle, and then write those locations into your ordered pairs. So those 2 spots on that circle, I've dotted them. That's when they cross the x-axis, so it's x-intercepts. The first one was at -1, -2, -3, -4, comma 0. The other one was at 1, 2, 3, positive, comma 0. Alright, so you should have all of them listed there. And you should notice something about them. So if you look at all your x-intercepts, what do you notice about all those x-intercepts? What do they have in common? Yeah, listen. They're all 0. They all have y values of 0. Each and every one of them. And that's not a coincidence. Because an x-intercept is something that's crossing your x-axis, right? Well, that means you started at the very center of a graph, and you went left or right, but you never went up or down. Otherwise, you wouldn't be crossing the x-axis anymore. So it's not a coincidence that the y value is always 0. So you never went up or down to find your x-axis. The important thing here is that all x-intercepts, no matter where they are, they have a y value equals 0. All of them. No matter what the graph looks like, if I'm telling you there's an x-intercept, it has a y value of 0. We're going to do the same thing now. We're going to look at the same 3 graphs. And we're going to look at their y-intercepts. So now you're going to look to see where they crossed the y-axis. And just like x-intercepts, there could be a lot of them on a graph. In graph 1, there's only one. It's right here. That's where the graph crosses the y-axis, and it's at 0, 5.
Why are they switched around? Like, for the x-intercept? Isn't it x first?
Yep, x goes first, y always goes second. So the x value was -3, right? I went 3 left, and then the y value was 0 because it didn't go up or down.
Oh, yes.
Yep. So for the y-intercept, the first one was at 0, 5. So I started at 0, then I went 5 up. I want you to try to find the next 3, if there is. So there's 1 in graph 2, and there's 2 for graph 2. And then I want you to fill in the blanks that they've left for you. All right, so if you did those, you should have noticed that on graph 2, it was 1, 2, 3, 4, 5, 6 up. So 0, 6. It didn't go left or right, but it went 6 up. For we grab 3, you should have gone 1, 2, 3, 4 up. So 0, 4. 4, 1, 2, 3, 4 down. So 0, -4. It's just like x-intercepts, y-intercepts have something in common. It's usually a little more obvious than the x-intercepts. What do y-intercepts all have in common? Someone other than Alyssa.
That x is always 0.
There we go. That saves the day. Alright, x values are all 0. Again, that's not a coincidence. If you're talking about something crossing a y-axis, that means it couldn't have moved left or right. It had to have gone straight up or straight down from the origin. That gives us a new rule. It's that all y-intercepts have an x value of 0. All of them. Doesn't matter how high it is, how low it is, they'll always have an x value equal to 0. These two things are very crucial and just need to be memorized off the top of your head. You're going to often hear me say, what do you know about y-intercepts? Because people will ask a lot of questions. They'll be like, I don't know what to do here. They didn't give me enough information. And I'm going to say, well, what do you know about y-intercepts? You know it has an x value of 0. If I ask you something about x-intercepts, you know it has a y value of 0. And that skill and that knowledge carries forward into 20s, so 20-1, 20-2, also carries forward into the 30 level, 30-1, 30-2. We just were doing this yesterday with the 20s. So they had to take things and just remember and automatically know y equals 0, x equals 0. The reason you need to automatically know that is you're going to get questions like this. This top stuff, it basically just sums up what we just said. Yeah, that's all it's really telling you. The bottom stuff is where we're going to pay attention. I know my slide looks a little different than yours. You have more writing on the bottom than I do. My writing is on the next slide so that it gives me more space to work with. I'm going to also slide this stuff up so I can really work with it. But the reason why what we just learned was so important was for situations like this. Because you're not going to get graphs given to you all the time. You're going to be given equations more likely than not. And with that equation, they're going to ask you to determine x and y intercepts without a graph. We're going to break it up into two parts. We're going to do, actually I want to do y-intercepts first. So we're going to do y-intercepts over here. We're going to do x-intercepts. So how you could determine your y-intercept without a graph and without guessing and checking. What do you know about all y-intercepts? That x equals 0. What that means is that you have an input given to you, but it's discretely given to you. Right? They didn't tell you x equals 0. You had to know x equals 0. And then you can put your input values into your equation to figure out what y actually equals. The way that looks, when I put that 0 in, I get 3y equals 5. Instead of x, I put bracket 0 bracket plus 15. And this is what we learned yesterday. You take an input value, you plug it into your equation, you'll be left with only one letter remaining in your equation. And then you can actually solve for your output value. Alright, to solve this thing, I no longer have any letters over here. So I can calculate this. I can put that entire thing into my calculator. If I go 5 bracket 0 plus 15, I get 15. So I have 3y equals 15. I literally put that in my calculator, this entire thing. The exact way it looks. Now that's good, like we're pretty close to being done. The question was, where's the y-intercept, not where's the 3y-intercept, right? You needed to figure out what y was, not 3y. So how can you get rid of that 3?
Divide.
You can divide. Why'd you know to divide? That's right. I'll let you try to answer that.
So, like...
How'd you know to divide?
Because they both go to that number.
Yeah, it works out perfectly,
and to
right?
get rid of 3.
And to get rid of the 3. Exactly. So, if you look at this thing, you have to ask yourself, how is this 3 attached to this y? How are they connected mathematically? If there's nothing in between them, that means they're multiplied together. To get rid of something, you have to do the opposite. The opposite of multiplying is divide. So you divide both sides of your equation by 3. When you do that, the left side of the equation cancels out. And I'm left with y equals 15 divided by 3 is 5. That means my y-intercept is at 0, 5. That's how you can algebraically determine x and y-intercepts. That was our example for y-intercept, which is a little easier than our example for x-intercept. Anybody have any questions about how I got that y-intercept? All right. Let's try to determine the x-intercept of this equation. The first thing is, you always have to have an input or an output given to you. You have to. They must have told you an x or a y value somehow. So if you know you're calculating a y-intercept, what do you know about your equation? For an x-intercept, what do you know about all x-intercepts, Charlie? You know that y equals 0. They've secretly given you one of the letters without actually saying it. That's the jump that you need to be able to make. You see what x-intercept, you know y equals 0. You then take that y equals 0 and you plug it in the equation to actually calculate what it equals. So your goal was to take that y equals 0, plug it into your equation. So you should have had something that looked like this. You should have 3 bracket 0 bracket, then equals 5x plus 15. Correct? Awesome. Usually when you substitute something in, you have something that you can actually calculate with your calculator. In our case, we could actually put that into our calculator. It's 3 bracket 0 bracket, that means 3 times 0. If you calculate that, it just equals 0. Now you might have just known 3 times 0 is 0, and that's fine. Alright, our goal was to figure out what our x-intercepts were, so to calculate x. You now can do that, because the only letter left in your equation is an x. The problem is the x is on the side of the equal sign with a lot of stuff. And it's 5x plus 15, and we have to somehow get that x all by itself. So we do something called isolating. I like to use the terminology reverse bedmass. Bedmass was something you guys learned. It's an order of operations on how to calculate things. Right? When I say reverse bedmass, what I mean is that if you look at your equation, you need to start moving these things. You're going to move additions and subtractions first. So you're going to do bedmass, but backwards. Right? So I need to move this plus 15 to the other side first. To move something, you do the opposite. So that plus 15, I'm going to subtract 15 from both sides. Notice that I'm not subtracting it from the 5x. I'm only subtracting it from exactly where it is, so it cancels out. and from the other side of the equation. So this gives me negative 15, and all that's left on the other side is 5x. Now if I continue with my reverse BEDMAS, I now need to remove any multiplications or divisions that are attached to my x. In this case, I have a 5 times x. The opposite of timesing is dividing by 5. When I divide one side by 5, I divide the other side by 5 as well. It'll cancel out on the one end, and then equal negative 3 on the other end. That means my x-intercept is at negative 3, 0. If you just put negative 3, I'd give you the mark. It's because I'm a happy-go-lucky person, and I'm really very generous in my marks. This gets you right, and it's just we normally write things in ordered pairs just to show that it's a point on a graph. So our x-intercept was at negative 3, 0. This process, this reverse BEDMAS, that's just a way to describe how to move things first. These are algebra skills. Right? So you're going to hear people talk when you need to improve your algebra skills or work on your algebra skills. They could not be more right for the next 3 units. Algebra skills are going to be crucial for the next 3 units. So if something like this was foreign to you, you were like, oh my goodness, I don't remember that at all. I don't know how he's moving those numbers. I don't know where they're coming from. Then you must practice these things. You have to. It's the only way to get good. And you have to come in for help if it's not working. So make sure in your practice booklet, you're practicing, checking your answer, making sure it's right. If it's not right, come find out why and get help. Because if you can't do these algebra skills, like you are going to suffer through the next three units. They're just so critical to everything we do. My advice to getting good at algebra, other than practicing lots, the first thing is don't try to do things in your head. Write down every single step. It makes a big difference. You'll notice I write in everything. I write in what I'm substituting. I'm writing in how I'm moving things. And after I do something, I always reorganize myself. And then I do my next step. Right? So I change something, I reorganize, and I write it nicely. I change something else, I reorganize, and I write it nicely. And I just keep it going, and I show every step. People who try to do this all in their head, they usually end up getting lost or make little tiny mistakes along the way. My second advice, keep things linear. Try to work down, not left or right. And then it's easy to keep everything kind of together. You'll notice that I try to keep my equal signs kind of all in a straight line. And that helps me keep everything nice and organized so I know where things are going. I actually had a math teacher who only let us work on half pieces of paper. So he took all of our pieces of paper and he cut them in half so that you had no room to go left or right. So you had to work up and down. And it was really smart on his part because it helped us. It forced all of us to work like this. And when you work like this, straight up and down, it keeps you organized. Right? So in your practice, if you don't have enough room to do that, just use some scrap paper or something. Keep yourself organized. It's huge to being good at algebra. Before we go on to the last question, my final piece of advice is if you found this super easy, which you might have, and you could look at that and be like, hey, the answer is -3, which you might have, still learn these algebraic steps. Because the algebra is going to become too difficult next year to do in your head. It's going to become too challenging to just figure out all this stuff. So if you are super strong at this stuff and you're able to just understand -3 would have made that all work out, still learn the algebra and get used to doing it because it's going to be critical in your next couple of years. Even though it might be a little tedious right now. Just make sure you understand it. All right, the last question is on the same page as what you have right now. It's just on the bottom of your page. I moved it to a separate slide so I have room to work. I apologize. Right after I say work nicely and straight up and down, you have no room to work nicely or straight up and down. So it should have been on its own slide, and I apologize. I'll show you how to do it. If you can write it somewhere else, maybe on the side of your paper. There's not too much algebra to it, so that's okay. Maybe you can do one on the left side, one on the right side. But this is a question exactly like the last one. It says you have this equation, determine, which means calculate, the x and y intercepts. We're going to split this into two parts again. We're going to do y-intercept. We're going to do x-intercept. To be able to calculate a y value or a y-intercept, I have to have an x value. What's my x value? How do I know it was 0? It always is. All y-intercepts have an x value of 0. It always is. X has to equal 0. It has to. That allows me to take my input value of x equals 0 and plug it into my equation. That means I have 0 squared plus y squared equals 16. Usually after a substitution, there's something I can calculate. In this case, I can calculate this thing. Yeah, box the whole thing. I can calculate 0 squared. 0 squared equals 0. 0 plus anything, does adding 0 to something change it? No, so this actually becomes irrelevant. And all we're left with is y squared equals 16. Because adding 0 to something does nothing. Now that's great, but I was looking for a y-intercept, not a y-squared intercept, right? So I want to know what value of y it is. How can I undo a square? Square root. Square root. You did a good one. I think it's your nose. So you square root both sides. That helps cancel out the square. And you have y equals 4. That means my y-intercept is at 0, 4. The last one we're going to do is the x-intercept. If I tell you to calculate an x-intercept or calculate any x value, then you must have a y value given to you somewhere. So this one's intuitive. You need to know it. So the value of y you know has to be 0. Because all x-intercepts have y values of 0. I've said it a lot of times, right? But it's because I'm trying to beat it into your head. You need that. You need that information to be there. I say x-intercept, you think y equals 0. Take that value, and we substitute it into our equation. By substituting it into the equation, you end up with x squared plus 0 squared equals 16. This one ends up solving the exact same way as the last one, but that's okay. So if you have 0 squared, that means we can pretty much ignore it because adding 0 doesn't do anything to an equation. So you're now left with x squared equals 16. I don't want x squared, I just want x. So what do I do to both sides? Square root. I square root both sides. That gives me x equals 4. That means my x-intercept is at 4, 0. That's pretty much the only thing that we're learning today. The biggest thing, the algebra skills, remembering how to get things isolated. You should have learned that, I think, grade 8 and done it a little bit in grade 9. And that x-intercepts have y values of 0, y-intercepts have x values of 0. If you came away and you feel you know that, then that's all you really need to get done today.